maybe not. The whole nucleus, the center of an atom, and electrons outside the nucleus. You know that elements must have, like all boron atoms, like they said, must have something in common. It's the number of protons in the center of the atom. The idea of compounds is also kind of something that you probably already have a sense for. Water is an example of a compound. How do we get, and usually people can tell me the formula for water is H2O. That must mean we have 2 hydrogens and 1 oxygen. Those 3 atoms must be stuck together somehow. We're going to talk about chemical bonds that stick them together. This is kind of the flow chart we started out with the other day. All matter is made up of atoms. It has mass and occupies space. We can, and I want you to kind of have a sense of this, we can classify matter as either being a pure substance, or a mixture. And the other day I kind of said, for instance, pizza is an example of a mixture. And there's 2 types of mixtures, and there's 2 types of pure substances. Our options for pure substance means that you have a pile of something where the atoms are all the same element, and we say you have an element. I'm trying to think of, I think I said an aluminum can. Like if your cans are actually all aluminum, then if you were to be able to put on glasses and look at the individual atoms, they would all be aluminum atoms that have, 13 protons in their nuclei. Okay. The other option for a pure substance is a compound. So I've got water in here. That repeating unit is this. Okay. So it's a pure substance. That's what makes it a pure substance. Okay. We're going to use chemical formulas to represent compounds. Your options for a mixture is it can be like well mixed, what we say uniform, a homogeneous mixture, or it can be chunky, a heterogeneous mixture. So I call this guy chunky. I don't know, for whatever reason, I like that term, chunky. Okay. So, and I kind of teased maybe the other day if you had somebody who had jaw surgery and they were craving a pizza, which pizza to me is a heterogeneous mixture. I mean, you can grab a little piece of the crust, you can grab a little piece of the cheese, okay, but it depends on where you kind of sample it. Sample at the bottom, you get the crust, sample at the top, you get the cheese. So it's not the same. You can stick it in a blender and and you can go ahead and homogenize it. Homogeneous mixture. Okay. So by definition, a compound, if you have a compound, then if you're going to be able to, it's a tricky thing to look at atoms, like with a telescope, with a microscope, and you have a fancy microscope, but if you look at atoms, you would see that 2 or more atoms of 2 or more different elements are stuck together. Okay, that's a compound. So these are examples of compounds: water, H2O, carbon dioxide, CO2, ethane, C2H6, calcium sulfate, CaSO4, magnesium nitrate, Mg. This one's kind of interesting. So if you've done much with math, you know that we can use parentheses in math to kind of emphasize a units that's kind of we stuck together. So here we have an NO3 in parentheses, and outside the parentheses we have a 2. It just means for that particular compound, it looks like this, where I have actually a center magnesium, and then I have 2 SO4 units. So here's my magnesium, and then I have stuck to it, NO3. N-O-O-O, N-O-O-O. See how that is Mg quantity NO3 2. So that's kind of what we do. The thing about compounds is you can take any compound, water or magnesium nitrate, and you can break it down into its individual little elements. Okay, that's why in the previous slide when it said pure substances, it said element and it said compound. I abbreviate compound CPD, and I kind of think if we can go back and forth, so I put a 2-way arrow, by a chemical reaction. Chemical, I do reaction RxN. So some sort of chemical reaction, we can go back and forth. No worries. We can build up elements into compounds. We can take compounds and break them down into elements. So yeah, compounds, we have elements, at least two different elements, if not more, different atoms or different elements stuck together in a repeating unit. Since you know what it's going to be, we just go ahead and write the formula for it. Now, this actually is in contrast to mixtures, because mixtures, I don't have a formula for a pizza. I can kind of randomly say what's going to be on my pizza, okay? And the thing about mixtures is I can kind of mix it up. I can do a lot of sauce, not much sauce. I can do a lot of cheese, not much cheese. But with compounds, you know what you got, and we just use a formula to represent what it is. If there is no subscript, we call these subscripts, like if somebody tells me the formula for water is H2, I'm going to put that as a subscript, okay? That 2, of course, goes with the hydrogen. Now, the fact that there's no number kind of to the lower right of the oxygen means that it's understood that I have 1 oxygen. So actually, so it looks like this. And we're gonna, I don't know if we'll get to it, talk about it too much, but kind of how I've drawn this angle of these hydrogens stuck to that oxygen, that's kind of how water is. It's what we say bent for a reason. Okay, but there's a water molecule. Okay, so this is another thing. If you have your sheets for your next unit exam handy, or just in your notes somewhere, I like kind of drawing, compare and contrasting these two types of compounds. So we kind of have a sense of compounds. You know, water's a compound, the magnesium nitrate was a compound. So we have two types of compounds. We have molecular, I'm going to make a columns here. Molecular CPD means compound to me, and ionic compounds. They have some things in similarity, and then they have some things that are different. The thing that they have that are similar is we use formulas to represent the atoms of which sort of element are stuck together in that repeating unit. So molecular compounds and ionic compounds, kind of compare and contrast. Here's our first thing to put on our chart. We're going to put this on the side of the molecular compound, and if we have a repeating unit of a molecular compound, we're going to call that a molecule. Go figure. Molecular compound molecule. So I'm going to put repeating unit is equal to a molecule. Molecule. I'll tell you that sometimes the word molecule gets used when it probably is not the best word to use. Okay. Now, you've probably heard of the word molecule. You probably have not heard of this one. If you have isolated a repeating unit of a compound that's an ionic compound, then you have what's called a formula unit. So repeating unit is equal to formula unit. Reagents like chemical bottles that we have in the chemistry storeroom, the old ones used to actually kind of have, they needed to for ionic compounds to refer to the formula unit, and they actually would call it no kidding, I'm just kidding. It's like, I'm not kidding. They call it an FU because formula unit. I'm sorry, but I just think that's funny. Okay. In general, we have something else to add. Compare and contrast. If you have a metal, so I'm going to kind of put it this way. I'll put both of these up here. If you have a metal in your compound is probably most likely 99.5% chance that the compound is an ionic compound. So this one is, you have a metal in the formula. And we've talked about how you can find elements on the periodic, their location on the periodic table to know if you have a metal or not. If you have a metal in the formula, then it's ionic compound. Over here, I'm going to say under molecular compounds, I'm going to say all nonmetals. How's that? Only thing you have in your formula are nonmetals. It's when you have a metal. And notice I say a metal. Any metal just kind of contaminates it, makes it an ionic compound. So I think I asked you this the other day, and I think you guys told me that table salt is sodium chloride. So actually, the formula for sodium chloride, I know because we kind of looked at writing a neutral formula. The formula for sodium chloride is that. And I could ask you on a test or whatever, I could say, just based upon that second criteria, I'm like, so what do you think? Sodium chloride is a compound. We would call a sodium chloride repeating unit a formula unit. And then, well, I guess I got ahead of myself. You already know now it's an ionic compound. And the criteria I just covered says we're going to look for the metal. And we can find sodium on the periodic table and chlorine on the periodic table. And if either one of them is a metal, it's an ionic compound. So here's my JAG. Okay, and there's the sodium, which that's a metal, and chlorine is a nonmetal. And we actually talked the other day, it gets all exciting, I think, that sodium forms a +1 cation, and chlorine forms a -1 cation. So it's kind of hard to get together in the first place. So I'll go ahead and say an example is sodium chloride. Now, the other thing I need to say over here with regard to molecular compounds is I'm going to say I put the letter H for hydrogen is considered a nonmetal for this particular check. So with that in mind, if we go to evaluate water, H2O, find oxygen on the periodic table, and I'm liking nonmetal. And based upon what I just told you, hydrogen's a nonmetal. So they're all nonmetals. So actually, I'm going to put example here is water. So it's fine to call water a molecule, but we should call sodium chloride a formula unit. Now, there are some exceptions to this, but that's generally how it works. All right. What else we got? Okay, so I'm going to go around the room. I think we left off with you, David. So I already said that one's molecular. What about this one, David? You have to have a periodic table handy. Carbon dioxide, is it molecular or ionic? Find carbon on the periodic table and oxygen on the periodic table, and if either one is a metal, then it's ionic. It is a molecular. Very good. Molecular. Awesome. Okay, so back to you, Genesis. What do you think about ethane? You have to find carbon on the periodic table. I already said hydrogen's a nonmetal. So if there's any metals, it makes it ionic. If there aren't any metals, it makes it molecular. It is molecular. Yep, very good. Molecular. Okay, Kaylee. Calcium sulfate. So now you're looking for three elements, the Ca, the S, and the O on the periodic table. It is ionic, because which one's a metal? Yep. Since this guy's a metal, it makes it ionic. Ionic compound. I do CPD for compound. So let's see what you think, Melissa. By nitrogen and hydrogen's a nonmetal on the periodic table, and sulfur. Is nitrogen or sulfur a metal? Right. So you would say If they're not a metal, then if they're all non-metals, it makes it.
Well, you just said on the other one that they're two metals and whatever.
I just said what?
You said that they're carbon. Yeah, if they're both metals, you just call them molecular, or whatever it's called.
They're both non-metals. Maybe I said it wrong. I think I do that sometimes. So I guess I would have to call that molecular. Which is not, but we'll call it that for now. Okay. I can go back and listen to myself. I'll have to go check. Get my lefts and rights mixed up too. Okay, one more, David. Look up and find on the periodic table magnesium, nitrogen, oxygen, and if any of them is a metal, then it makes it ionic. If they're all non-metals, it makes it molecular.
Yeah.
Yep, because magnesium's a metal. Very good. Metal, ionic. Awesome. Okay. Very good. This one actually, I kind of already did an example of this when I did water. I said, or just today we said we can use the decimal number on the periodic table to know how much an atom weighs, and units are going to be used, or atomic mass units. We could actually want to know what the mass of a molecule or a formula unit is, and all we got to use is the periodic table to come up with it. You guys have phones and or a calculator. Let's go ahead and let's see. I've already done the first one. So if you would, Genesis, if you do CO2, okay, so just in your, write it down. And then Kaylee, if you do C2H6. And then Melissa, if you do CaSO4. And I'm leaving you a hard one. So David, if you do NH42S, that would be awesome. Do you guys understand what I'm having you do? I'll do the first one to kind of show you what it looks like. And it's going to look like this up here on the board. So out in the margins, if I wanted to know what the mass of a water molecule is, I would take 2 and times, and I have my periodic table handy, times 1.008 U's plus 1 times 16.00 U's. And again, this 1.008 and the 16.00 came from the periodic table. And I would tap it in, I come with 18.02 U's. I'll do the last one. So 1 magnesium. It's heavy.
Oh, you gotta add. What are those?
Right or not, but that's for what it is.
Yeah.
It's got a two from that 200.
Oh.
So it will be 2 nitrogens, 2 units would comes in, so you have two nitrogens and 8 hydrogens.
Also, it's 6. Then.
So there were two moles and 4. So two nitrogens.
So then I know what
Good. Yeah, that's what I think too. This guy. Okay, so I saw what y'all worked with, looks good. So carbon dioxide, and I'll just write up your answer. What'd you come up with, Genesis?
44.1.
44.01 U is how much one molecule weighs. So we call that the molecular mass. Very good. So Kaylee, what'd you get for the C2H6? 80.0682. Oh, sorry.
30.068.
Sorry. 30.0.
And then units.
Thank you. Very good. Okay. Awesome. And Melissa?
136.15 units.
Very good. Awesome. And then, David
Did you
had
get
this.
91.118?
I think so. That sounds right.
That's what,
91.118
yeah.
and use. And so David had the tricky one. So I don't know if you can follow my scratchings up here, but what he had to recognize is, I'll draw it on the board what that means, is you kind of go from left to right with regard to, if you see something outside, parentheses right here, that means you have two of those. So in this case, that means I have two NH4 groups. So it looks like this, where in the middle I've got my S for my sulfur, and then I have two NH4 groups. So here's one NH4 group, and here's the other NH4 group. And the compound's formula was NH4 quantity 2S. So this is reflected in those two groups. So if you kind of visualize it that way, you can see what I set up on the slide is I'm going to have to have two nitrogens, and the decimal number for nitrogen is 14.01. I'm going to have 8 hydrogens, decimal number is 1.008, and I only have 1 sulfur. So kind of think of it that way. Okay, very good. All right, so this actually is a good place to stop, and it will be just on the heels of all that we've already kind of talked about with regard to compounds. So page 361, exercise number 4. That'll also be due the Monday after spring break. Oh yeah! No one's going to want to come back, but we do. We must. Everybody come back. Some good stories to tell. All right. Cookie for the road, people. I want them all to go away. This year, I don't know if it's new, but the Girl Scout that I bought from, you can buy Girl Scout cookies for like troops and stuff. Like, so you don't have to get the calories, but you can help the Girl Scout person. And they're purchases that you don't